Hey guys, welcome back. In this video, this is actually the second part of adding or subtracting rational expressions. So we're going to be working with things that look like this and kind of putting everything together. So like I said, this is part 2. So if you are not familiar with finding LCDs and how to make equivalent fractions, you might want to go back and watch part 1. I'll put a link to that in the video. So let's start by looking at just what do we do with plain old fractions. So if you watched the last videos, you should know how to find the LCD at this point. So the first thing that I'm going to do, right, is I'm going to break apart 6 and 15. And then from there, I will find the LCD. And we talked about kind of the most efficient method for finding the LCD in that last video. So this example was already outlined. So now what we want to do is actually just kind of combine everything together, and if we can see how to do it with this case, then I think we'll understand kind of what to do with rational expressions. So just to kind of make this nice and visual, so remember 1 over 6, so this is 1 over 2 times 3, and so you want to make this look like this basically, right? So what is it missing? Well, it's missing that times 5. And then for 1 over 15, so 1 over 15 is 3 times 5. So if I compare this to the LCD, I can see that it's missing the 2. So I'll multiply this by 2, and whatever I do to the bottom, I do to the top. So here's kind of the work that's involved. So just a note on this. This is one way that you can do the work. I'm going to just run through a second way that you can do the work in a moment. So I'm doing all of the work just right in the problem. So then I just kind of go through and do piece by piece. So 1 times 5 is 5. And then the LCD is 30. So this is 5 over 30. And then for the other one, so 1 times 2 is 2. And then the bottom here is going to be 30. So this is really what you need when you want to add two fractions with unlike denominators. You just need to get them a common denominator. And then in the end, it's just a matter of adding the tops. You bring the denominator just along, and then in the end you get 7 over 30. So this is one way that you can do this work. I think one thing that is very important is that you need to make sure that you are doing the work in a way that makes sense in your brain. So for some people, when they do all the work in one step, this gets overwhelming. And so if this is overwhelming to you, don't do math this way. Instead, respect the way that your brain processes things and switch it up. So let me just very quickly show you a different way you can do this that I've seen work for some students. So I've had some students tell me they prefer to take each fraction separately. So maybe I'll just kind of show you the idea here. So I've got 1 over 6 and I've got 1 over 15. So I've seen some students who will take each fraction separately and go ahead and get that denominator, get the common denominator. So remember this LCD, so this all of this equals 30. So the other way I can think about this is what do I have to multiply 6 by to get to 30? So I know that's 5. So I have some students that will go ahead and just work on each fraction separately like this. And then I take the 1 over 15. I multiply that by 2 over 2, so I get 2 over 30. So they work on each part separately, and then they take those two pieces and add them together. So in the end, now I've got 5 over 30 plus 2 over 30. So that's all the work that I did for those separate pieces. And so in the end, I still get 7 over 30. So this is very important that you think about what way is going to make the most sense for you. Some people are fine with having all the details in one place. Some people want to take their time and kind of go through the details. So think about that as you are doing some of these examples. So where I want to start are just 2 examples to let you just try the whole process. So go ahead and do the subtraction here and hit play when you're ready. Okay, so first let me just write out what the LCD is going to be. So I'll do the work over here. So my LCD is 70. Again, if this process doesn't make sense to you, it's very important that you kind of understand the pieces of this. So if you didn't watch the first video, you might want to go back and watch it. So next I can work on getting my equivalent fractions. So I will do this using the first method. I'll switch up the methods back and forth. So I've got 7 over 10. So what do I have to multiply that by to get to 70? I have to multiply the top and bottom here by 7. And then I've got 35. So I have to multiply 35 by 2 to get to 70. So here's my work. So then I ultimately have 49 over 70 minus 6 over 70. And so in the end, I get 43 over 70. And that's as far as I can go with that one. Okay, so let's do just one more. So again, we're just trying to put everything together, and these are nice, quick ways just to kind of refresh your memory. So once again, let's go ahead and find the LCD and then do the whole process. If you want to pause the video, go for it. So first I'm going to find the LCD, so I'll do the work over here. And now I'll work on getting my equivalent fractions. So this time I'm just going to go piece by piece. So I'll break this into 2 pieces. So first I'll start with this one. So I need to multiply this by 3 on top and on bottom. So that's going to get me 6 over 63. And then working on this other one, so for 2 over 9, so for this one I'm going to have to multiply the top and bottom here by 7. So this is going to give me 14 over 63. So now I have to just take each one of these and combine them. So I've got 6 over 63 plus 14 over 63. So that's going to be 20 over 63. Now just a last note here, sometimes when you finish this, you'll be able to simplify this. So when that happens, of course, you do want to actually simplify. So now that we've kind of reviewed the general process, I think we can move on to what to do with rational expressions. So again, in the last videos, we actually talked about how to get your equivalent fractions. So this is kind of just an extension of that concept. So I think you probably know kind of what to do here. So if you want to try the 3 of these, go for it, pause the video, or go one at a time, whatever works for you. So starting with this first one, so I already know what my LCD here is going to be. I did a lot of examples with this in the last video, so let me write out the LCD work. Okay, so my LCD is 42xy. So now I just have to kind of think through that. So using the first method that I showed you guys, so I have to figure out how do I make 21xy now look like 42xy. So I have to multiply now the top and bottom by 2y. So I guess I'm using the second method here, sorry. So this will be 4y over 42xy. So there's the first one. Now if I work on the second fraction, so I've got 5 over 14y, so I have to multiply this by 3x on top and bottom, and I get 15x over 42xy. So now I'm going to combine these two. So I get 4y over 42xy plus 15x over 42xy. And so notice in this case, so this is going to be how this really changes. So depending on what you multiplied by with rational expressions, you might not actually be able to combine these things. 4y and 15x are not like terms. So for this one, as far as you can go is just 4y plus 15x over 42xy. Also note, you cannot reduce this. You can't like divide 4 and 42 by 2 or by anything else. You can't divide like 15 and 42 by something. You can only do that if you could factor something out of the entirety of the top. So don't let yourself start canceling like one term at a time. You have to make sure whatever you want to cancel out, you can factor it out of the top. So factor the whole thing out of the top then, and then make your cancellation. That's the only way you can do that. Okay, so moving on to the next one. So same number for my LCD, just slightly more complicated with the letters. So now I've got my LCD here is going to be 42 x to the 4th, y to the 3rd, z to the 5th. And so once again, let's go ahead and just kind of work this out. So I've got 2 over 21 xy cubed. So I need to multiply this now by 2 x to the 3rd, z to the 5th, and then in the bottom, maybe I should change these to stars so that you know it's multiplication, not an x. So whatever I do to the bottom, I'm going to do to the top. So there's what I'm going to multiply for the first one. And then for the second fraction, so now I'm going to multiply this by 3y, and that's it. So now you work this out once again. So I'm going to get 4 over x cubed z to the 5th over 42 x to the 4th y cubed z to the 5th minus 15 y over all that. And so once again, you don't actually have any like terms here, so this is just going to be kind of this big, not beautiful answer. But that's all you can do for that one. Okay, so one more now. Let's go ahead and find the LCD. And now we can go through with working on the fractions. So I've got 8 over 35x squared z cubed. So what do I need to multiply this by? So I need to multiply this by 2x to the 4th, y to the 3rd, and whatever I do to the bottom, I do to the top. And then I'll do that for the other one. So I've got 7 over 10x to the 6th, y to the 3rd. So what do I have to multiply this by? 7 z to the 3rd, whatever I do to the bottom, I do to the top. So let's keep going with this. And so if I combine these, I get 16x to the 4th, y to the 3rd, plus 49z to the 3rd, over 70x to the 6th, y to the 3rd, z to the 3rd. And so notice once again, I cannot factor anything out of the top. There's no like GCF or anything here. So I can't reduce this any farther. So this is as good as it gets. So now we've seen how to do this with just single term kind of monomials in the denominator. So now what I want to do is start making this a little more difficult. So I have these other examples. So again, if you are not familiar with finding the LCDs of these types of things, definitely watch the other video. Pause and go ahead and try these and play as you're ready. So for this first one, so my LCD now is going to be 5x to the 3rd, x minus 2. So now I can just go ahead and work on these. So I'll do these one by one. So I've got 4 over 5x cubed. So now I need to multiply this by x minus 2 over x minus 2. Now remember, we talked about in the last video, you definitely want to multiply out the top. Oops. But you don't necessarily have to multiply out the bottom. So the reason for that, you'll start to see kind of why that is in this video. So let me just finish this and then you'll kind of see why I keep telling you that you have to multiply out one but not the other. And I guess I didn't need the parentheses there, but I'll just go ahead and finish this. Okay. So in this example, I've gone ahead and worked out each fraction separately. So now I just need to kind of combine these. So let's go ahead and write that out. Okay, so notice what I've done in this example. So I know since I'm combining both of these top pieces over the same denominator, I just went ahead and wrote out kind of the top all combined just to see what I've got. So in doing this, I'm actually kind of done unless I want to write this in descending order, in which case this looks like. But once again, I can't factor anything out of the top here, right? So there's nothing that will evenly go into all of these terms. So once again, this is as good as it gets. So let's move on to the next one. So here my LCD is. And so let's go ahead and do the work here of getting the equivalent fractions. Now here's where this is actually going to start to get a little more interesting. So as I work this out, so you want to be very careful of this minus sign. This is going to be where you get kind of thrown off. So let's go ahead and kind of work this out, and I'm going to show you a couple different ways that you can kind of deal with the minus sign. So the first way is just kind of pushing ahead by multiplying out the tops together. So let's go ahead and do that. Okay, so this is where this gets kind of tricky. This minus sign applies to the entirety of this top. So you have to be extremely careful now when you're kind of combining these things. So let me show you what I mean. You could kind of think of it as maybe this minus sign is going to all of this. So the way that this will combine will look like this. So now you can see, right, that you have to actually distribute this minus sign in so that you can finish this problem. And this actually really kind of changes things if you look at it this way. So if you only subtracted the 3x squared, that's going to give you a totally different answer. So this is one of the really tricky things now when you're actually adding and subtracting it. It's like a nuance that you don't get when you're just trying to find the denominators. So let's go ahead now and distribute. So it looks like this. And let me just clear off a little bit of space so I can finish this. So I'll move the problem. Okay, so now you can see that the 3x's are actually going to drop out here. And so my final answer then is going to be negative 3x squared minus 6 over the denominator. And notice in this case, so I can actually factor something out of this. I could factor out technically negative 3. So this will look like, and so now that I've factored this out, you can see I actually can't make any cancellations. But this is kind of the process of what you want to go through if you're trying to cancel things out. So let's go to the next problem. So now here, I'm going to have to factor both of these polynomials to find the LCD. So let me do all of that work first. And so there's my LCD. So now what I want to do is just clear out a little bit of room so that I can move forward with the problem. So now let me work on getting my equivalent fractions. So here's the work that I need to do, and now I want to show you just another way that you could kind of set up these problems. So I like showing you all these different ways because these types of problems now, the idea is simple, but the actual execution is a little tricky because there's just so much that you're writing down. So you do want to be really careful with this. Notice what types of mistakes you make, because that should really inform how you're writing out your work. So the mistakes you make is what determines how you should be doing your work so that you are more likely to prevent mistakes. So another way that you can do this is before you start multiplying out, say like the tops here or the tops here, you can actually just kind of write this problem out in another step. So let me show you what that looks like. Okay, so check this out. Now I have everything over my common denominator, but now I can see what I actually have to multiply out, and I can kind of just push forward this way. So this is a little bit different from the last approach. I'm showing you just all these different ways. Choose what works best for you. So let me go ahead and distribute. And now I'll write the answer up over here. And so now that I've gotten it to this point, now you can determine if you can simplify. So the only thing I could factor out of the top here would be 2, so this would look like. And so notice now with how I've written this, I can't cancel out any factors here. So once again, this is the final answer. This is as good as it gets. Okay. So now we've kind of got the basic idea with working with polynomials. So I have 3 more examples here, kind of just playing off of that idea. And then we'll look at one other thing and then we'll be good on this topic. So go ahead and try these and hit play when you're ready. Okay, so once again, I'll just show the work real quickly for finding the LCD. So I'll go ahead and factor everything out. So there's my LCD. So now let me clear off some room and then we'll continue on. Now once again, I want to point out this minus sign is going to make this a lot more difficult. So double check your work and see if maybe you want to pause and change what you wrote out, just in case maybe you have to correct what to do with this minus sign. So I'm going to do the method now where I talked about at the beginning of this video. So this time I'll just do fraction by fraction. So I'll start with this one and then I'll do this one and I'll just do all the work just so we can kind of compare that approach. So let me go ahead and do this. So that's as much as I can do with the first fraction. So now let me work on the second fraction. Now notice with this one, I need to take x plus 1 times x plus 7. So I actually need to FOIL all of this out. So this is going to be a little bit of work now. So I'll go ahead and show you just what the foiling looks like. And now I just need to collect my like terms. Okay, so now with this approach, I need to take this fraction minus this fraction. So let me clear off a whole bunch of room and I'm going to leave just this piece and this piece set up. So I'll clear this out. Okay, so here's what I was left with. And the thing that I'm nervous about now is this minus sign, because I really need to make sure that I capture this minus sign and I subtract off the entirety of this. So what I mean is you kind of want to think about like there being this set of parentheses around here so that you can properly distribute this minus sign in. This is such an easy error to make that I highly recommend that you actually take the time to write out all the details to force your brain to slow down. So let me show you what I mean. What I'm going to do is I'm going to rewrite all of this. I'm going to distribute out this minus sign, and then I'm just going to have everything over the same denominator. So let me just show you. Okay, so you can see now I actually went through and I forced myself to think through these details so that I wouldn't miss it. And now I can go ahead and finish this. So I can just like, you know, collect my like terms. So now I've got 2x squared minus x squared. So this is x squared. And then let's see, 10x minus 7. And then this is going to still be over this whole denominator. And so now that's as far as I can go with this particular example. I can't factor this any farther. So that's all I have to do. Okay, so moving on for this one, let me go ahead once again. I'm going to find my LCD, so let me write out all the factorizations and do that. So there's my LCD. Let me make some room. So this time, the approach I'll use is I'll just do the whole problem just right in one go, so I won't break it down. So I'll go ahead and write out the work. Now what I'm going to do is I'm actually just going to write kind of all the work that I need to do here. I'm going to write it all over the same denominator so I can kind of move from there. So this is what I'm going to do. Okay, so now you can see I have to do a whole bunch of foiling here. So I'll go ahead and do that. Okay, so let me clear some room so I can keep going with this. And now I'll go ahead and distribute the negative and then collect my like terms. Okay, so there is my final answer, negative 9x minus 16. So that's the final answer. So if you didn't get to that, and then over, of course, the x plus 5, x plus 4, x minus 6. So if you didn't get that, my guess would be that you probably have a minus sign error somewhere in here. So really check your work and make sure, like, if you skipped over some of these steps, It's very common, even though I know that the calculations are not so difficult. It's very easy to make a minus sign error with this. So even though the math is not complicated, like I said, there's just so many X's and letters here, it's so easy to make a mistake. So if you are making mistakes because you're just doing too many steps in your head, then you really need to take the time to write out all of this. I'd rather write out a couple extra steps and get it right than save time and get it wrong, because then that doesn't really help you. And notice with this, so I can't really go any farther with this, so this is as good as it gets. So for this one, I have a bunch of examples on just finding the LCD with this if you haven't checked them out. You can look at some of the other videos. So this was covered in part 1. I also had a video with extra examples with this if you need some practice. I'll go ahead and find the LCD. So like I said, if this is just totally foreign to you, you should definitely watch the other videos. I talked all about this in the other videos, so I'm just going to keep going from here. So let me clear some space. So just as a reminder here, you do have these 2 minus signs, so you do want to be really careful when you're doing this. Now, a final way you can kind of do this is you might be starting to kind of see the pattern as to what you're going to multiply with the LCD. So like this is x plus 2 and x plus 3. So you know here that you need to multiply this by x minus 3. So you can start kind of compressing some steps if you aren't making mistakes. Some people are just prone to mistakes with this. Some of us just think very, very quickly. So it's not a matter of your intelligence. It's just how you kind of process details. So if you need to work out all the details, just do it. Okay, so let's go ahead and work through these pieces. I guess I'll do it maybe in 3 different pieces here, just to kind of see what I need to multiply each piece by. So I'll break that out and then I'll start combining stuff. So let me work these out. Okay, so there are all my pieces. So once again, I'm just going to clear out some room here and then kind of line up what I need to do so that I can keep moving with this. So let me clear some room. Okay, so this problem is getting pretty ridiculously huge. So I just want to kind of also put in my signs here, and I'm going to put parentheses around everything just so I can see what I got to do next. So let me write out all the work here. And now I'll go ahead and collect my like terms to get the final answer. And so there's the final answer. I can't factor this any farther, so this is going to be as good as it gets. So let's just switch gears a little bit here. So I have just 3 examples now of another concept that we talk about a lot. So kind of working with factoring out -1 to make this work. So I talked about this also in the last video. So hopefully this is familiar to you. So take a stab at these. Hit play whenever you're ready. So for the first one, so just think about what the LCD here actually is. So the LCD is just x minus 3, right? That is the LCD. But what you have to do here is you actually have to make a manipulation here. So when I do that, so what's that actually going to look like? So I'm going to leave the first fraction alone. So I know that if I factor the negative out of here, this is going to flip the whole order of the bottom. And so then it's just, what do you actually do with this negative? So I've mentioned this before. This is kind of a little fact. So if you have negative a over b, this is the same thing as negative a over b, which is the same thing as a over negative b. So it doesn't matter where that negative goes. So basically now we just have to transfer this in place here. Because that's all equivalent anyways, and that makes more sense for the context of this problem. So a lot of times you just move the negative to where it makes the most sense, and sometimes it doesn't matter where you put it. So this will actually become 2 over x minus 3 minus 7 over x minus 3, and now you can just finish this, right? So this is just going to be 2 minus 7 over x minus 3 to get -5 over x minus 3. Okay, so with that in mind, let's try the other two. So I'll start by factoring to get my common denominator. Okay, and so in looking at this, I know that I can turn this 5 minus x into x minus 5 if I just make a little manipulation here. So I'll work through those details in a second, but since I know this, so my LCD then is going to be... Okay, so with that in mind, let me clear off some space and then we'll work on the other part of this. Okay, so let me rewrite this 4 over 25 minus x squared. I'm going to rewrite that as 5 minus x and 5 plus x. So just notice that this could turn into really negative 4 over x minus 5 over 5 plus x. So like I was saying in the last example, so it doesn't matter where you put that negative. So I actually intentionally moved the negative. Instead of it being down here, I just intentionally moved it up here. And now I can see also what I need to multiply this whole fraction by. So I just need to multiply it by 2 so I get to the LCD. So I'll just do that on the top and on the bottom. And so that's the work that I need to do to the first fraction. So this whole thing then will equal negative 8 over the denominator. Okay, so now for the other fraction, so I'll just take this as 3 over 2 times x minus 5. So for this one, then I know I just need to multiply this by x plus 5 or 5 plus x, doesn't matter which way you want to write it. So this will equal then 3x plus 15 over the denominator. And so now what I need to do is just take this minus this. So let me clear some room and just kind of write that out. Okay, so I've got now the first fraction and the second fraction. So remember, I am subtracting all of this. So I just want to be mindful of that. So let me write that out. And that would be the answer for that one. Okay, so for our last problem, so of course we know we need to factor. So, in the interest of time, I'm just going to write out the factorizations. And so now I can see that I'm going to have the old -1 trick problem here. So I want to manipulate this expression here. So I'm going to rewrite it with a big old negative out in front like this. And then that will help me to choose my LCD. So my LCD is going to be x minus 4, x plus 4, and then x minus 3, because now I can see the x minus 4s are in common at least. Okay, so now I need to work on kind of manipulating these expressions so they have that LCD. And actually one thing I want to do, this negative, I'm actually going to write it on top here so that I don't like lose it. You can transfer the negative to the top, so I'm going to do that. So I'm going to just kind of cancel it out here and leave it up here. Okay, so now let me work on getting these all set up. Okay, so I've got my first fraction here and it's all factored. So what I need to multiply it by is going to be the x minus 3. So I will do that on the bottom and on the top, and then let me write out the second one. So there's my second fraction, and so we know that we need to multiply this by x plus 4, so I went ahead and did that. So now let me write all of this good stuff out. So I've got all the same denominator now. So let's just write this out now with the top pieces. So I've got negative 3x times x minus 3. I'm going to go ahead and write that out, negative 3x times x minus 3. So there's the first part. And then I've got this minus 2 times x plus 4, all of that over this common denominator that we've done all this work to find. And so now to finish this, I need to start distributing and trying to simplify the top as much as I can. So let me clear some space. And so now I've got negative 3x squared plus 9x minus 2x minus 8 over all that jazz. And so now if I look at what like terms do I have? I've really just got the 9x minus the 2x, so this is negative 3x squared plus 7x minus 8, all of that over that denominator. And so now I just have to think to myself, so does this factor? And let's think. This guy here will not factor, so we are actually done and good to go. So if you found this video helpful, please consider leaving me a like. I love it when you guys leave me likes or comments with questions, and subscribe and share this channel if you found this helpful. And otherwise, thanks a lot for watching, guys. I'll catch you in the next video.